All right, let's look at this problem. We've got a conical water tank, and its height is 12 feet and its radius is 3 feet. Water is being pumped in at 4 feet per minute, cubic feet per minute. How fast is the water level rising when the water level is 6 feet? Okay, I want to talk about this just in general for a little bit before we solve the actual problem. If you've got a conical water tank and you're pumping water into it at a constant rate, then during that, say the first minute that you're filling it up, you're going to put some amount of water in there. During the second minute, you're going to put the same amount of water in there. Maybe it's only like about that much. But because the tank is wider up there than it was at the bottom, during that second minute, the water level is not going to rise as much as it did during the first minute. And just in general, over time, the water level is going to rise more slowly until you get to the top. So let's draw a good picture of our tank and come up with what we need, the equations that we need. Okay, so here's our tank, and they're telling us about how much water is being put into it. So that's talking about dV dt, water is being pumped in at a rate of 4 cubic feet per minute. So that's dV dt is 4. Let's say how fast is the water level rising when the water is 6 feet. Okay, I need to draw the water in here. So here's my tank. Let's say this is the water level here. And so underneath that we've got water. All right, that's close enough. So when we're talking about volume, dV dt, we're talking about volume of water. So that's the volume of this down here. So let's look at this. The water itself, its radius is r and its height is h. So we need a formula for the volume of a cone. Formula for volume of a cone is 1/3 pi r squared h. It's kind of interesting where that comes from. If you have a cylinder, the volume of that is pi r squared. That gives you the area of the bottom times the height. So pi r squared h. If you have a cone instead, you put a 1/3 on the front. All right, so we've got that, and we're given dV dt. And what else are we given? We're given dV dt, and we're asked to find how fast is the water level rising. So we're asked to find dH dt when the water level is 6 feet. So when h is 6. Okay, so what we need to do is this equation over here. What we need to do really is first we need to eliminate the r, because we're given dV dt, we're asked about dH dt. So let's rewrite this getting rid of the r. Now we can do that using similar triangles. On this tank over here, the height of the whole tank is 12 feet, and the radius of the whole tank is 3 feet. So using similar triangles, what we can say is 3/12 is equal to r over h. Now I'm trying to get rid of r, so let's solve this for r. This gives me r equals 3h/12, or h/4. So if I take that and substitute in for this r, what I get is volume is 1/3 pi times h/4 squared times h. So that gives me volume is 1/3 pi h squared. Well, let's see. The 1/4 down there makes this 1/16, and then h squared times the other h gives me h cubed. So I can finally put all this together and get pi over 48 times h cubed. That's my, I've done so much work to get it, I have to put a box around it. But that's our equation that relates the two quantities. Now to get the rate equation, erase this stuff down here. To get the rate equation, we want to take the derivative of this with respect to time. So the derivative of v with respect to time is equal to pi over 48 times 3h squared times dh dt. And let's see, that 3 and 48, we could put those together and cancel them, or reduce it to 1 over 16, but let's do that in the next step. So what were we given? dv dt is 4. Find dh dt when h is 6. So let's plug into this. Let's see. dv dt is 4. We get pi over 48 times 3 h squared. H is 6. And dh dt is what we're trying to find. All right. So we've got 4 equals pi over 48. Let's see, 3 times 6 squared, that's 3 times 36. I think that's 108. Yeah. So let's see, dh dt is 4. So I'm going to multiply both sides by the reciprocal of this. So over here I get 48 on top, and I get 108 and pi on the bottom. Let me grab my fraction calculator. Not that I can't do this in my head, but it's easier to do with a calculator. Or at least I can do it on paper. So let's see, 4 times 48 divided by 108. That gives me 16 over 9. And the pi is still on the bottom. So 16 over 9 pi. And if we write that as a decimal answer, it's 0.56. Let's round to 3 decimal places. 56588, so 0.566 feet per, what were our units? Minute. All right. So that's kind of a long problem, but that's how fast the water would be rising at that point. All right, that's it.